Good morning, grade 12 students. Welcome to another FB live streaming of Physical Science Quarter 2, Week 3, Light as a Wave and a Particle. Light is intimately involved with our daily lives. Many unique properties of light are extremely fascinating. Here, we will take one step closer to the wonders of light through its well-known basic properties. So based on our most essential learning competencies, so these are the following. Number 1, describe the propagation of light, reflection, and refraction are explained by the wave model and the particle of model of light. Number 2, explain how the photon concept and the fact that the energy of a photon is directly proportional to its frequency that can be used to explain why red light is used in photographic dark rooms, why we get easily sunburned in ultraviolet light but not in visible light, and how we see colors. But before we begin, let us have a simple game first. It is entitled Name This Color Challenge. In 20 seconds, all you have to do is to state or say aloud the colors of the word and not the word itself. I repeat, you have to state or say aloud the colors of the word and not the word itself. So, are you ready, guys? Timer starts now. Okay, time's up. Seems so confusing, right? Why do you think so? Okay, let me try. Um, it's red, it's a yellow, it's a green, it's blue, it's pink, it's yellow, it's brown, it's green, it's blue, it's yellow, an orange, and a green. Seems so confusing. But why is it so? So the reason why is because your right brain tries to say that the color, but your left brain insists on reading the word. So now you know. Okay. So why do you think is it a light? Is it light is a wave or a particle? So light has the properties of a wave and a particle. The word wavelength is used to express the wave or undiluting property of light. Our eyes can only see light that is of wavelength between approximately 400 to 700 nanometers. So this range is called the visible light. The light of other wavelengths includes X-rays, ultraviolet rays, and infrared rays. Though we cannot see them directly, they are also members of the light family. On the other hand, light also has the property of a particle. The intensity of the light varies depending on the number of particles. Bright light has many particles, while dark light has fewer particles. So these particles of light are called photons. So in this video, it explains how light travels in photons, which can be described as both particles and waves. Einstein showed that photons can be described as particles using the photoelectric effect to show that the energy of photon is related to the frequency and Planck's constant. The quantized nature of light can be found in both spectral lines and the photoelectric effect. So based on Einstein-like quantum hypothesis, the duality of the photon was confirmed quantum mechanical experiments and examination. The photon is now regarded as a particle in fields related to the interaction of material with light that is absorbed and emitted, and regarded as a wave in regions relating to light propagation. Okay, so we have the what we call the reflection of light. So we perceive almost 80% of the world around us by using our sense of sight. So where does light come from? Natural light comes from the luminous objects such as the sun and light bulbs. We say that these objects emit light. We know that when waves run into a boundary, they are partially transmitted and partially reflected. So we have the sun, fluorescent bulb, burning candles. They generate their own light, and they are what we call luminous objects. While those objects that cannot generate their own light, like for example, the table, the chair, the wall, and the paper, they are what we call the non-luminous objects. So light behave as a wave. So it is reflected. Therefore, an object does not need to emit photons itself to be seen. It just has to reflect light back to our eyes where we can detect it. When a ray of light approaches smooth polished surface and the light ray bounces back, it is called the reflection of light. The incident light ray which lands upon the surface is said to be reflected of the surface. The ray that bounces back is called the reflected ray. If a perpendicular were to be drawn on a reflective surface, it would be normal. The figure above shows the reflection of an incident beam on a plane mirror is an example of a reflection of light. Okay, what's next? So we have the what we call the refraction of light. So this time, when we see refraction, it's the change in direction of a wave passing from one medium to another or from a gradual change in medium. Refraction of light is the most commonly observed phenomenon. But other waves such as sound waves and water waves also experience refraction. How much a wave is refracted is determined by the change in wave speed rather, and the initial direction of a wave propagation relative to the direction of change in speed. Okay, an example of a refraction of light is a broken pencil. Why is this phenomenon observed? The explanation of this phenomenon involves the refraction of light. As the pencil is moved across the middle of the glass, an interesting phenomenon is observed. The position of the pencil under the water is shifted relative to the position of the pencil above the water. And that's the reason the pencil appears broken. Okay, how about how about how does the rainbow form? So let's have an experiment. So using the flashlight, focus the light towards the prism. If you have a prism at your home, and observe what will happen as it strikes on the prism. Do you see any colors? So look at our figure and list down the colors seen based on how they were arranged. Okay, so I think you've seen different kinds of color. So white light is not a single color. It is made up of a mixture of the 7 colors of the rainbow. Why? Is it because this one experiment demonstrates this by splitting white light with a prism, and that effect is what we call dispersion. Light is made up of wavelengths of light, and each wavelength is a particular color. The color we see is a result of which wavelengths are reflected back to our eyes. Okay, so the colors of the rainbow, the range of colors is called a spectrum. A rainbow is a meteorological phenomenon that is caused by reflection, refraction, and dispersion of light in water droplets, resulting a spectrum of light appearing in the sky. It takes the form of multicolored circular arc. Rainbows caused by sunlight always appear in the section of sky directly opposite the sun. So when sunlight encounters a raindrop, a part of the light is reflected and the rest enters a raindrop. The light is refracted at the surface of the raindrop. When this light hits the back of the raindrop, some of it's reflected off the back. When the internally reflected light reaches the surface again, once more, some is internally reflected and some is refracted as it exceeds the drop. Okay, so kindly look on the illustration. So based on the illustration, how is the color of the light reflected to its to its wavelength and frequency? So as you can see, we have the color red, orange, yellow, green, blue, and violet. And we have the corresponding wavelength and the units nanometer, the frequency is terahertz. Like for example, the red color, the wavelength is 650 nanometers and the frequency is 462. Orange, we have 600 nanometers, the frequency is 500. Yellow has a wavelength of 580, the frequency is 517. The green, the 530 wavelength, frequency 566. The blue color has a wavelength of 470 and the frequency is 638. What about the violet? It has a wavelength of 400 and the frequency is 750. So based on our illustration, how can you relate the wavelength and the frequency? So as you can see, the red color has a longer wavelength, which has 650. But in terms of the frequency, it has the lowest frequency. In our color violet, it has a shorter wavelength because we have only 400 nanometers. While in its frequency, the violet color has 750. So it has a high frequency. So the higher the frequency of the light, the higher the energy of the wave. Since color is related to energy, there is also a direct relation between color, frequency, and the wavelength. Okay, so the question is, why red light is used in photographic dark rooms? Okay, the explanation is here. Dark rooms use red lighting to allow photographers to control light carefully so that light-sensitive photographic paper would not become overexposed and ruin the pictures during the developing process. Because of the popularity of digital photography today, dark rooms are not as popular as necessary as they once were. Okay, next. So why we get easily sunburned in ultraviolet light but not in visible light? So physicists classify EM or electromagnetic waves according to their wavelength. The shorter the wavelength, the more energy. UV waves are shorter than visible light waves. So UV possesses more energy than regular light. So UV photons have the right energies to cause chemical changes. When UV light hits your skin, the DNA in your skin cells can undergo chemical change. There you go, guys. It's quiz time. Let's try to answer the following questions. You can type your answer in the comment box. Then, let's see. Okay, question number 1. So Clark wants to give a bouquet of yellow flowers as his Valentine's gift to Leia because yellow is her favorite color. However, he bought a wrong choice of color, which is green. Luckily, he knows some magic tricks by using his spotlight. So which of these spotlights do you think he will use to make it yellow? Is it a blue spotlight, B, a red spotlight, letter C, a white spotlight, or D, an orange spotlight? So you can type your answer in our comment box. Okay, the answer is letter B. So it is a red spotlight. Next, number 2. Leia and Clark are at the Luneta Park. Suddenly, a rainbows appeared. They are arguing which among the rainbow colors has a long wavelength but with a low frequency. Which color is it? Is it A, blue color, B, an indigo, letter C, a green, or letter D, a red color? What do you think is the answer? Type your answer. Okay, time's up. The answer is the red color. Okay, number 3. A rainbow is a meteorological phenomenon. light in water droplets, resulting in a spectrum of light appearing in the sky. So it takes the form of a multicolored circular arc. Rainbows caused by sunlight always appear in the section of the sky directly opposite the sun. Which of the following properties of light causes rainbow? Is it A, reflection, B, refraction, C, dispersion, or letter D, all of the above? Type your answer. Okay, time's up. The answer is all of the above. Okay, so it's very good. So I think all of you got the correct answer. Thank you, learners. This has been your teacher. I'm Miss Lorena General. Stay safe and stay healthy. Have a good day. Bye.